I want to welcome you to this particular channel again, where we produce content on topics relating to chemistry, biochemistry, and various other subjects. I would like to talk about buffer. A buffer system generally is a system that resists change in pH. It doesn't allow you to have a much change in the pH of a solution, and most times such systems usually contain a weak acid a weak acid, and the conjugate base of that weak acid. Or you can also have it as a weak base and the conjugate acid of that acid of that weak base. So these are the major components of every buffer cylinder. Either you have this or you have this. Now, and from what I've said earlier, you can imagine when you have a system that has a weak acid at the same time the conjugate base of that weak acid. So that implies that if you had let's say an acid to that particular system, which whereby an acid is a solvent that produces H plus. There is already a what? There is already a base in that particular system that can remove all the added H plus altogether, such that the change in the pH of that solution will not be what? Will not be much. In the same manner, when you had a base to a buffer system, which is supposed to remove H plus from that particular system, there's already a weak acid in the buffer system to let me say reduce the effects of that particular base. So the conjugate base in the buffer system will do what? Will reduce the effect of adding an acid, while the weak acid in that particular system will reduce the effects of what? Of adding a base. And that's how buffer works to resist change in the pH of a particular solution. So with buffer system, you can maintain your solution at a particular pH. So an example on such system is when you have, like I said, CH3 COOH, and you have Na, let me just say NaOH, giving us CH3OONa plus, and we have H2O. So such system as this, because this is an acid that doesn't dissociate completely altogether. At the same time, you are having a salt which can also break down. So in a system like this, you will have some weak acid being present in that solution. At the same time, you also have some CH3COO minus. This is a what? This is the conjugate base of this weak acid. So this can what? This can remove the effect of what? Of adding an acid to what? To a buffer system by taking up all the what? All the H plus. But this one can what? Can reduce the effect of adding a base to a buffer system by releasing H plus. Therefore, the whole buffer system resisting change in what? In pH. So this is the conjugate base of this particular weak acid. But when it comes to a base, you can have something like probably ammonia and what? And ammonium. So this is the conjugate acid of this weak base. This is a weak base, and this is what? This is the conjugate acid of this weak base. So you can have this pair, or you can also have this pair. Another example that we also always have is this. You can also have H2CO3 and what? And HCO3, which is bicarbonate buffer, which is also the buffering system that we have in the what? In our body fluid. So you can have this the weak acid, and this is the conjugate base of this particular weak acid. Another common one that we also have is this, which is H3PO4 and H2PO4 minus. This is also a weak acid, and this is the conjugate base of that. So every buffer system we have this, either this pair or this particular what pair. So buffer generally works with a 6 pH because there is a what, there is a conjugate, there is a base that can reduce the effect of adding a word, that can reduce the effect of adding an acid to the system, and there's also a word, an acid that can reduce the effect of adding a base. So in that manner, the pH of a buffer system will not change, but there is a limit to the buffering capacity of any buffer system. And most times, if you want to use any substance to produce a buffer, the pH range for any substance to serve as a buffer will always be that you have the pKa will be the pKa plus or minus 1. That is, must be in the what, in this particular range. So let's say probably for this part, let's say the pKa of this weak acid is, let's say, 4.78. So that means that if I want to use this substance as a buffer, it must be between what? It must be the range of 3.78 to, let's say, 5.78. Another way, let's say probably for this, let's say it is 7.2. So if I want to, I'm just giving all of this pKa as an example. They might not be the specific for this for each of these weak acid. So the pH range for you to use this one as a buffer, if the pKa is 7.2, will be what, 6.2 to 8.2. So you have to be careful when selecting a weak acid to use for your buffer. You have to be careful so that you not pick a weak acid that will not work best at your desired pH. Generally, for a buffer system, or let me even say for weak acid, when you want to calculate their what they call now, their pH, the pH of a buffer system, you can simply use this formula, which is equal to pKa plus log of concentration of the conjugate. Now, which can either be a base or an acid, over the concentration of either an acid or the base. So if you have a weak acid there, this one will be conjugate base. If you have a base here, this one will be conjugate acid. So, and this is the formula that we use as applies to what, a buffer system. So, but then it's not every case that you will use this formula. It is not in every case that you can use this formula out there. So if you know if they give you any buffer system, you know the pK of that buffer, and you know the amount of what, amount of conjugate acid or base in that buffer, and the amount of acid present in that particular buffer, you can determine the pH of that buffer. In another way, they can also ask you to go in the opposite direction, such a way that they will give you the pH of the buffer, they will give you the pKa, and they will ask you to determine the amount of conjugate acid and the base that is present, or conjugate base and the weak acid that is present. So you can also go in this particular way. They can even ask you to prepare buffer of a particular pH using a particular weak acid and the conjugate base pair. So, but they will have given you, that means you will need the pKa, and then you can determine the ratio of the conjugate base to the amount, to the ratio of the weak acid, and then you can now use that to prepare the buffer they want you to do, and that is very basic. So this is only applicable, this in a way is only applicable when you have a buffer system. Now the question to ask yourself is, when do you know that you are to apply this formula, and when do you know you are not to apply this formula? Now, in a case whereby you can have, whereby they said some questions may tell you that they are having a buffer system, so that means you already know that this is the formula to apply to get either the pH or whatever they want you to calculate in that particular. But in some questions, they will not identify that you are having a buffer system, so you have to be the one to tell me, am I to apply this formula or not? Now, this is one way to know. Now, in most cases, in some cases, they can give you can prepare a buffer using using a weak acid, let's say COH. and a what? A strong base. Now, because you know that when you have a solution of a weak acid, it will partially what? It will partially dissociate such a way that you are going to have H plus, some H plus, and then some CH3 COO minus. Now, in a way, you can now add altogether. You can add what we call now. You can add NaOH in a way. You can add NaOH to this particular solution of the weak acid to produce more of this, and this one, the amount of this one will be what will reduce, because this will what will dissociate more, and then the amount of this will increase while the amount of this will reduce. But in some cases, the amount of NaOH added might be more than the what than this particular the amount of the amount of weak acid that you have. So in such cases, that means that all this will be what will be all of this will be converted to what to this particular conjugate base. So, and in such particular occasion, this will no longer work. So anytime the amount of NaOH you are adding to a particular weak acid system is more compared to the amount of weak acid that you have there, then this formula does not apply. But anytime the amount of NaOH you are adding is less than this, then you can still apply this formula to get the pH for that particular weak acid system. So what I'm saying there is that, so when the amount of NaOH is greater than the amount of CH3 COOH, so that means that here this is not a what, so you can apply this, so you don't apply this, because the NaOH you are adding will convert all this weak acid to this, and this will no longer be in the what in the buffer system, in the solution system. So, and that means that you are no longer having a buffer. But when NaOH is less than the amount of the weak acid you are having, what that implies is that it is not all of this that will be converted to this. So in the solution, which in this case is a buffer, you will have some of this remaining, and you also have some of this. To understand what I'm talking about better, you can, let's say we have 0.5 of this, and then we have 0.1 of this. Now, initially, some of this will dissociate, but when this dissociates, the extent of dissociation of this particular weak acid is very small, such that the initial dissociation will give approximately zero amount of this acetyl ion. So in a way, this place will be zero, while this place will be approximately what 0.1, because this one does not dissociate to a large extent. Even when you check the Ka value of this, you will see probably around 10 raised power minus 4 or 10 raised power minus 5. That's the Ka of this particular weak acid. So the amount of this one that will be produced in the initial dissociation will be very, very small. That's the first thing to take note. So now imagine that if I add 0.5 molar of what we call of this strong base to this system, what happens is that all of the 0.1 molar of this acid will change to what, to this, and the amount of this will approximately becomes what, zero. So, and that means that in this particular expression now, this place becomes zero, and this one will be approximately 0.1, and any number divided by zero will give us what, will give us infinity, and that means that this expression becomes what, becomes undefined. So, but in the case, that is for this particular case where the amount of sodium hydroxide that you are adding to this weak acid is very high compared to the amount of this weak acid that you have. So in such case, you don't apply this formula. together. So and what that implies that what will later determines the amount, the pH of such solution will be your what, your NaOH, because the amount of it is very very high compared to this. Now but in a case whereby you have that the amount of sodium hydroxide you are adding is less compared to this, let's say probably you are adding 0.02 molar of this strong base to this particular system. So what happens is that it is only small part of this that will be changed to what, to this. So that means that the 0.02 molar of this strong base will react with 0.02 molar of this weak acid, which will produce what, 0.02 molar of this what, of this conjugate base. Now but what happens is that what will happen to this is that initially you have 0.1, but 0.02 of it has been removed by what, by the strong base. So what will be left here will be 0.02 minus 0, and that becomes what, 0.08. So in this case you are having considerably, let me say you are having reasonably concentration of what, of this weak acid, which is 0.08, and this may be to the concentration of what, of this conjugate base is what, 0.02, and that makes this what, this formula applicable. This formula, like I said earlier, is only applicable if this is what, if this is true. At the same time, in cases whereby you know the amount of what, of the conjugate what, of the conjugate base, at the same time the amount of the what, of the weak acid. So if the amount of these two is reasonable, if the amount of them is reasonable, you can easily use what, this. But anytime you have a question or a situation whereby the amount of this one is not like is approximately 0, or probably the amount of this is approximately 0, then this formula does not apply. And I hope we get that. So the only situation to get this, especially when you want to use a word, a strong base to probably prepare a buffer. So in that case, this will only be applicable if the amount of NaOH you are adding to this particular weak acid is small compared to what you have for the what, for the weak acid. The same thing applies when you have a what, a weak base. So in the case of a weak base, let's say probably you are having probably ammonia, and then you are adding HCl2. HCl is a strong acid, this is a weak base. So in a manner as this, so if the amount of this you are adding to this system is very high, so that means that this formula will not be applied. But if the amount of this strong acid you are adding to this system is very low compared to the original amount of this, then you can apply this formula. But for the sake of basis, what we have, like I said earlier, is what we are going to have there will be POH equals to PKB plus, that will be log of, so here let me probably write acid here, and this will be what, conjugate base. But that will be what, this one will now be what, conjugate acid over the what, base. And that's the formula to use. So when you get the pH, like I said from the beginning, POH and pH can be added together, and that will give us what, 14. So and this is what we use in solving problems involving a buffer system. But in some cases, some people will use a weak acid and the salt of that part of the conjugate base of that weak acid to prepare their buffer. For example, if they use CH3COOH and CH3COONA. Now this salt can produce the conjugate base, and then you have raw. So this makes a buffer. But in some cases, like I said, some people will use a strong base added to this weak acid to produce a buffer. So in this particular case, you just need to determine the amount of CH3COO minus that we produce from this salt, and then you also determine the amount of acid used, and then you also determine the pH in this case. But in the case of you probably adding a strong acid to a weak base to produce a buffer, you have to consider the amount of the conjugate base produced after adding this strong base to the what, to the weak base. And in most cases, the amount of the conjugate base produced is always similar to the amount of strong acid or strong base added. And when you remove the amount of strong acid or strong base added from this weak acid or weak base, you will get the what? You will get the amount of this Mr. Man you are going to use here, of this weak acid you are going to use here. And that's how to solve problem in formula. But please take note, I said that you will only apply this formula if the amount of strong acid or strong base you are adding to either your weak acid or your weak base is less less. But if the amount of strong acid or strong base you are adding is more, then this formula will no longer be applicable. So you fall back to what I discussed at the beginning of this video. I hope this video particularly is just to give us a kind of understanding of what we have to do when we are faced with problem involving pH, whether for an acidic solution or whether for a basic solution, or even when you have a buffer system. So I'm not doing any particular example in this video, but I hope you understand the basis of things that you have to do when you are given a question involving any solution, any aqueous solution. So I hope in this particular video you have learned one or two things which you can apply to solve any problem given to you. Probably in the subsequent video, I would do a video whereby I'm going to be working some examples on this particular topic so that we can have a better understanding of what I've discussed with you in this particular video. I hope that you would do well to like, to comment, and at the same time share this particular video with your fellow students who you know can also be in need of this particular video, especially for students in biochemistry and chemistry, even people in clinical sciences. This video can be very important. And if you have any question, please do well to drop it for me in the comment section. Or if you have any problem you want me to help you to solve, you can also do well to drop it in the comment section or try to contact me, and I would be willing to offer any help that you need. So once again, thank you for watching this video, and don't forget to not just watch the video but also do well to subscribe to this particular channel. Thank you so much.